Okay, so this will be the medical chem portion review. And so we're going to go through these various questions. And what we'll end up doing is I'll go ahead and answer each of these and explain a little bit. We're going to be using the equilibrium system as our basis for most of these questions. So let's go ahead and start on it. Okay, so let's start with the respiratory system. Okay, and that's going to involve carbon dioxide and water. And that is going to combine to form carbonic acid. And that is then going to produce bicarbonate and give off a hydrogen. Okay, so then what we're going to do is we're going to go, and this is an equilibrium. So then what we're going to do is we're going to go ahead and simplify this. Okay, so essentially we're going to get rid of all this in here. And now we have just a giant equilibrium system where here's our reactants on the respiratory side, here's our products on the metabolic pathway. As indicated by as driven by the renal system. Okay. All right, so here's how we're going to do basically these. So first of all, it says what polyatomic ion functions as a buffer in the blood? Well, that's going to be the bicarbonate, HCO3 negative. Now, a buffer for carbonic acid is bicarbonate ion, which is, by the way, a conjugate base. So a good buffer for an acid is its conjugate base. So bicarbonate is one. Which answers the second question. Bicarbonate is the correct answer. Number 3, fast, heavy breathing helps to blow off CO2. Okay, so if we're exhaling a lot of CO2 as in hyperventilation, that's going to decrease CO2 concentration. If we take, it's going to go towards. Okay, as such, H plus is going to decrease. And that's really when we're talking about these, we're talking about what happens to the pH. Okay? If there are less hydrogen ions in solution, that means that it's going to be less acidic, more basic, and therefore have a higher pH. Okay? So effectively increasing the pH. Number 4, so pH, we'll put pH here. pH increases, right? Bases have a higher value on the pH scale, greater than 7. Slow and shallow breathing retains CO2 as CO2 increases. Okay. Equilibrium is going to shift. Now, if we add, it always goes away. If we add the left, it goes to the right. Hydrogen is going to increase, making it more acidic, which is a lower number on the pH scale. So pH goes down. Number 5, acidosis. Well, that would be when there's a high concentration of hydrogen ions in the blood. And alkalosis is when there's a low concentration of hydrogen ions in the blood. Compensation. Well, what happens is when one of the systems, the pH is out in one of the systems, what will happen, for example, if there's too much carbon dioxide? Okay. That's going to produce a lower pH, acidic solutions, as we just saw. Okay, and what can happen if for example, our conditions are too acidic? What the metabolic or renal system can do, it can increase bicarbonate. So if we add, it goes away. Okay, that is going to then lower the hydrogen. Lower the hydrogen ions. Okay, because the arrow, remember, the direction shift arrow is not pointing towards it, so that decreases. Okay, thus increasing the pH to a more normal region. Okay, just likewise, if the hydrogen ion concentration is, let's say we're in metabolic acidosis, in which case we have too high too much hydrogen. Well, what are we going to do? What can the respiratory system do to compensate? Well, what can happen is we can get rid of more CO2 if we take, it goes towards, and thereby that's going to lower, thereby that's going to lower the concentration of hydrogen ions. Okay? As such, the pH is going to increase, right? It's going to become more neutral or more basic. All right, so system number 7 regulates pH by way of CO2, respiratory. So the respiratory can change pH based upon CO2. The renal system, or the metabolic pathway, can regulate blood pH with the bicarbonate ion. Okay. Number 9, which system regulates blood pH by way of bicarbonate? Let's get a new screen here. So number 9 says, which direction of shift would take place if bicarbonate increases? So if the metabolic pathway increases bicarbonate, if the kidneys increase the concentration of bicarbonate, add always goes away, and that is going to decrease the number of hydrogens, right? Remember, if our arrow, direction of shift arrow, is not pointing towards, it's going to decrease. That's why hydrogens decrease. Okay, pH. That, if we have less hydrogens, it's more basic, right? Which bases have a higher number on the pH scale. Let's see. Number 10, what polyatomic ion does lactated ringer solution contain to prevent acidosis? Well, here's what it does basically. Lactated ringer contains, for one, sodium lactate. Sodium lactate is converted in the kidneys to the bicarbonate ion. Okay. So essentially that takes care of number 10. Number 11, what is low-dose aspirin and what is its use? Well, low-dose aspirin simply is just less aspirin per pill, lower dosage of aspirin. Okay. Number 12, besides reduced pain and reduced inflammation, what benefit does aspirin provide to those at risk of strokes? Well, it also can act as a blood thinner. Number 13, aspirin functions to relieve pain by blocking COX-2 receptors. Okay. And that will about do it for the review.